All right, so the second half of the related rate lesson, basically, this lesson is going to be me working two examples. So I'm going to read through it. The area of a rectangle is increasing at a rate of, so you know this is something dt, right? Area, so it's going to be dA dt. While the length is increasing at a rate of, so again, as soon as you see those words, you know that it's dt. So since this is length, I'm going to call it dl dt at a rate of 3/2 centimeters per second. Again, not a physics class. We don't give a damn about the units, but I have to put them there. I want to find the rate of change for the width, which would be dw dt, at the moment that the length is 5 centimeters and 2 centimeters. So my advice to you, if you remember correctly, was to draw yourself a pretty picture. You don't always have to draw a picture. I'm going to use capital L because my lowercase l looks funky because it's a weird script L. So here's my rectangle. Remember, the area is the space inside. And if you remember back from the 3rd grade, the area of a rectangle is the length times the width. Right? So step 1 was always read through the question, make a picture if necessary. I mean, I didn't need to, but I drew it anyway. Write a formula down if you're not given one. I wasn't given one, so I had to write that. The area of a rectangle is length times width. Now, the second step was to read through it carefully and write down everything that I know. So that first sentence is telling me a lot. It's telling me that the area is increasing at a rate of 18. So they're telling me that dA, A for area, dt, is 18. Why is it centimeters squared? Because it's length times width. This is centimeters and this is centimeters. So when you multiply them, you get centimeters squared. But again, not a physics class. We don't give a damn, but I'm telling you anyway. Let's see, the length is increasing at a rate of 3/2. So that means that dl dt is 3/2. Let me make a little squiggly here. Keep them separate. I want to find the rate of change for the width. That's dw dt. I don't know what it is. I'm looking for it. Now again, I'll explain the situation. This rectangle is growing. I wish I could do special effects. I probably could, but it's too much work and time. The rectangle gets bigger and bigger and bigger, okay? So the area is growing at this rate, and the length is growing at that rate. I'm trying to figure out what the width is growing at. So I'm going to freeze. So as it's growing, poof, I stop. I stop the rectangle from growing at the exact moment that the length hit 5 and the width hit 2. I could have stopped it at any other point in time, but I chose to stop it at that point in time. So I know that the length is 5 and the width is 2. At the moment that I chose to freeze my rectangle from growing, it's getting bigger. Okay, so the next step was to take the derivative with respect to t of both sides. So that's what I'm going to do. The derivative of a was dA dt. The derivative of L is dL dt, right? 1. The derivative of W is 1. dW dt. You know, that seemed a little too easy. Let's see. dA, derivative of A is 1, dA dt. Derivative of L, dL dt. I get this funny feeling that I did something wrong.
What about the product rule?
Oh my god, the product rule. I completely forgot. I took this derivative wrong. I guess I better fix it then. Okay, with the help of my little magic pixie, who informed me that I screwed up and I needed to use the product rule. I mean, this is a product. It is what it is. You can't take derivative of this and multiply them. That's just not how it works. So I did first, derivative of second, derivative of w's dw dt, plus second derivative of first. And I know some of you do this backwards, and it aggravates me and infuriates me to no end, but whatever. 2 plus 3 and 3 plus 2 are equal, so I let you get away with it. But I like first derivative second plus second derivative first. So if you want to keep me happy, then use the product rule in the way that I do it. Now I'm going to plug in everything that I know. I know that the area, what is dA dt? It's the rate at which the area changes. I know that that's 18. 18 what? Who cares? Centimeters squared. The length, remember, this rectangle is changing, but I froze it. I froze it at the moment in time that the length is 5. I don't know what the width is changing. That's what I'm looking for. That's why I put a question mark there. The width is 2 when I froze my rectangle from growing. And then the length is changing at a rate of 3/2. Well, how convenient. Look at how I rigged this. So I'm going to go cross those out. 5. I'm going to write a little smaller. It's not going to fit. All right. Now I'm going to take you back to the 5th grade. Subtract 3. Cross it out. Do red, make it all pretty. Well, do you see? I rigged it so nice. Usually these answers come out, as you guys know if you've been practicing the first sheet, these answers come out obscenely nasty oftentimes. They're usually kind of nuts. I rigged this one to come out rather nice. So I just divide by 5. So that means that the width is changing at a rate of whatever 15 divided by 5 is. I need to use my fingers. So 3. 3 what? 3 centimeters per second, but who gives a damn? Again, not a physics class. I don't care about the units of measure. You tell me 3, I am thrilled. All right, so I took my derivative, plugged in everything I knew, did a little bit of algebraic manipulation and arithmetic, and pow, I got 3. Okay, so this is the first example. The reason I did this example, because it's a lot more complex than it appears to be. People take this derivative wrong very, very often. And if you do this derivative wrong, you're going to be screwed over. You might also see one with a triangle. It might be the area of a triangle. Area of a triangle. Area of a triangle. Pi r squared? No. Area of a triangle is half the base times the height. That works for any triangle. Even a right triangle. Even a non-right triangle. Doesn't matter. But see what's here? BH product. So when you take that derivative, product rule, and trust me, you will be doing one with the area of a triangle. All right, so I'm going to do the next one, which is harder. Okay, so the next question, you're going to have to let the horror of this one sink in a little. Sand is pouring from a chute and forms a conical pile. What? Whose height is always 6 times its radius. Yeah, that makes sense. The radius of the cone, oh, it's a cone, hence conical pile. Okay, I understand. The radius of the cone is increasing at a rate of 1/2 foot per minute. Okay. Find the rate of change for the volume of the cone at the moment in time that the radius happens to be 3 feet. Oh, brother. Let's see. Let me try to draw a cone. Poof. The cone is there. And yes, I drew this on the first try. I just didn't want you watching me. All right, so you have sand pouring. And it just forms a pile. And the pile, if you've ever watched sand being poured from something, it does kind of form a cone-like shape. I mean, it's not a perfect cone. So it makes a pile like this, okay? The radius depends on how much is there, right? I mean, further up here, this radius is not the same, right? Everything is constantly changing. The radius, as the pile gets bigger and bigger and bigger, the radius is getting bigger and bigger and bigger. And so the volume is getting bigger and bigger and bigger. So this is what you're trying to figure out now. Do I expect you to know the volume of a cone? Sure. It's half the base times the height. No. It's pi r squared. No. But you know what? There is a circle in the cone. It's the bottom of the cone. So it is kind of in there. This is one of the formulas they give you. This question does tend to show up on the department final. And they give you this formula. It is 1/3 pi r squared h. Look, volume is 3 things, right? Length, width, height. If the volume of a room is the length times the width times the height. So with a cone, you basically have the circle there, and then you need the height. But the problem is that the radius is changing depending on where you are on the cone. That's why the 1/3 is there. It's kind of an offset of that. All right, so this would be given to you. Do you need to draw the picture? No, I just drew it for fun. So this is it. I have my formula. Now I'm going to read the question carefully. I'm going to write down everything that it tells me. All right, I took the liberty of writing it just to save myself 2 seconds of work here and blocking the camera. So it says here the radius of the cone is increasing at a rate of 1/2. Increasing at a rate of, so it's dr, r for radius, and they use lowercase r. So dr dt, this is the rate of change of the radius. This is the rate at which the radius is changing. It's 1/2. dv, I know my r and my v look very similar. I tried not to make it curvy. I'm going to fix it and I'll make it a big V. Big V. So there's no mistaking my R and my V. My R tends to look like a V and it's pretty bad. This is why I should use a capital, but they just don't. So I want to find the rate of change of the volume of the cone. So I'm looking for dV dt. At the exact moment, I'm going to freeze the cone when the radius hits 3 feet, which is pretty big actually. Now, there's one more piece of information they told me, and it was in that very first sentence. It says sand forms, blah, 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 forms a conical pile. Love that, conical pile. Whose height is always 6 times the radius. So the height is 6 times the radius. I'm not sure how that would be useful. Okay, so I'm sure they didn't just tell me that for nothing. So let's go through. I'm going to take the derivative of this. So here I know I'm going to get a dv dt. Here I'm going to get a dr dt. See, here's where I'm going to run into a question. When I take the derivative of h, I'm going to get dh dt. That's the rate of change of the height. That's how fast the height's growing. This question says not a damn thing about the height. I don't know nothing about dh dt. And I can't have another unknown. I already have an unknown. I already don't know dv dt. I can't also have dh dt. You can't have 2 unknowns. So the reason that they told you this is to get rid of this. You need h to be gone. H has to be removed. You have to replace it with r so that the whole thing has nothing but v and r. And that's all I have. I wasn't giving anything about dh dt. So you have to be very, very slick when you read these. You have to read them really careful. Sometimes they'll give you dh dt and you got to get rid of r. And that's much more of a pain in the ass because r is being squared. But here, since I'm doing it, I made it a little easier for myself. So I'm going to replace h. This problem is harder when you have to replace the r. I'm going to replace h with 6r. They're telling you that the height is 6 times the radius. So wherever the height is, put 6r. Now look, before you take the derivative and do anything silly like, oh, there's a product, use the product rule. Don't be ridiculous. You have r squared and r. These are the same letter. Put them all together before you take the derivative, okay? So, and you know what? I'm gonna do even better. I'm going to take 1/3 of 6. Just do 6 divided by 3 is 2. Pi, r squared times r1 is r cubed. So, and again, see, my r looks like a V. The curse of horrible handwriting. There, better. This is your formula. This is what I'm going to take the derivative of. Take the derivative with respect to t of both sides. Neaten it up first, okay? Make it look all pretty before you do the derivative. It's just going to be easier for you. So poof, there's the derivative. Again, I'm doing this to save time and you know, writing. Watching me write's kind of ridiculous. Take the derivative of v, it's dv dt. Right? Taking the derivative with respect to t. I mean, look, I'll write it if you want. That's what I'm taking. The derivative. Bad marker. Derivative of that whole formula with respect to t. Now, 2 pi, stay, you're like, where the hell did the 6 come from? I multiply by the power. Remember, I'm taking, pi is a constant, 2 is a constant. Remember, you don't mess with the constant. You leave the constant there. So multiply by the power. 3 times 2 is 6, and then subtract 1 from the power. So the derivative of r3 is 3r squared, but that 3 hooks up with the 2, makes 6. Subtract 1 off the power, and then dr dt, because letters don't match. If you took the derivative of like t squared with respect to t, it would just be 2t because the letters would match, but you're never ever going to have a t in any of these formulas. You're going to have all sorts of other crap, L, W, V, A, H, all this other stuff. So that's the derivative. Now I got to plug in everything I was given and see if I can fit this in one space. All right, so I started my plugging in. 6 pi. You leave this alone. What the hell are you going to plug there? There's nothing to plug. Okay? Now, R, remember, I'm freezing my cone at the moment that the radius is 3. So R is 3. Plug that in. Now, the rate at which the radius was changing, the radius was increasing at a rate of 1/2. So where dr dt is, you put the half. There it is. It was there, and I plugged it in. Now, look. Take half of 6, right? Be smart here. Cut 6 in half and get 3 pi. And then do 3 squared, which is 9. Let's see, I might have to use my fingers. These are big numbers. I don't know, 3 times 9. Let's see, 9 plus 9 plus 9. So, don't do nothing weird. You don't got to put 3.14. You don't have to put 180. You certainly wouldn't put 180. I mean, if you were going to actually do this, you would do it by 3.14, but screw that. Same thing. You don't have to put, now remember, this is volume. So this would be cubic feet per minute. Forget about it. Who gives a damn? You get 27 pi, then I'm riding high. So are you. All right, I'd be very happy. So go through it again real quick. Picture, optional. Formula, given to you. So you didn't have to do nothing. But you did have to replace H with R because I didn't know anything. The problem didn't tell me anything about the height. It didn't tell me that the height is changing at a rate of. They didn't say that to me. So I cannot take the derivative of H because I would have got dH dt. So I had to get H out of there. That's why they told me the first sentence that the height is 6 times the radius. I replace H. I make the formula look all pretty. Take the derivative with respect to T. Boom. Plug in the stuff. Pow. Get your answer. All right, so that was the second example. Another worksheet will be uploaded, and you can have lots of fun banging your head against the wall doing this insanity. So all I will do is wish you good luck.